Sziasztok!
Hi all. I'd like to talk to you about a lot, but I don't have too much time. So I'll just skip the unnecessary parts like introduction. Hi, my name is Zsombor Kovács. I love beer. Before proceeding, who of you has there been a Wi-Fi workshop before? No, not yet. Oh, okay. I wanted to ask you who attended, but the question is unnecessary in this case. So I'll talk about Wi-Fi. And as I checked the agenda, I managed to give it quite a long title, and the translators abbreviated it pretty much, replacing it with something similar. So we'll be talking about Wi-Fi. And from the point of view of, okay, when you look at Wi-Fi security development, how Wi-Fi security developed over time, then you'll find a very interesting trend. When this whole Wi-Fi thing got off the ground, well, you can debate the exact year, but it was a very attractive technology and became used increasingly, and increasing number of security problems turned out to be in the system. One was that over-the-air wireless data were sent unencrypted. They can be listened to, and around 2000, roughly, wireless listening became more widespread. The first encryption attempt was WEP, WEP. Who has already broken WEP? Great. Who has clicked more than twice while doing so? Right, so you were not using the backtrack tools that need 2 clicks to crack a web code. So when it turned out that web is totally unusable for encrypted traffic, then came WPA, which used the same hardware architecture that was used under web, but had a better key management, which provided quite a good security. WPA 802.x was quite good. Obviously, they are only good if the system is set up well and the network is okay. Then the attack surface is not too big. I currently do not know of any attack that would succeed independent of the type and length of the key and independent of everything else. So WPA or WPA2 802.11x systems cannot really be cracked in a general manner. Wi-Fi, however, is much more vulnerable against denial of service attacks than normal wired cable networks. The reason I have discussed this, talked about this, is that as we today see, the network is less and less vulnerable, and attackers concentrate primarily, for the reasons I've just explained, that there are no silver bullet attacks, are turning towards the clients, because client protection is a bit lower level, so clients are a lot more vulnerable than a well set up network. So we are investigating the threat where an attacker installs a malicious access point to which clients connect later on. And the root of the problem is that for the clients cannot really identify the network structure without a pretty big infrastructure. The network has a few important parameters like the name of the network and the access point address. And a for a Wi-Fi client, these are the two bits of information that decides whether a network is known or not. If you look at the order 2.x standard, then you will see that these things all go in clear text. So if I observe the MAC address that goes through the network, then I can impersonate those MAC addresses in most of the cases. I've also written about exploits that target the Windows drivers of wireless cards. For instance, in Metasploit's current repo, there are a couple of such things. What we utilize here, okay, wireless clients not only monitor beacons passively, but also, in a general case, they have a list of what networks they like to connect to. And they broadcast to find these networks, saying, this is my MAC address, I'm looking for this and this AP. These also go in plain text. And if we as attackers respond, we can get these clients, the wireless cards as well, to connect to our access point, believing that we are authentic. This wireless access point is about this much worth for the clients. There's a couple of data that you can impersonate, and from that point onwards, you're trusted by the clients. I'm not talking about the 802.x authentication system. Now, what happens when a Windows client, it could be any client, it's just an example. If the client connects to the network, Windows clients in the first couple of DNS requests provide information about themselves and about the network they are normally living on, about the domain. And these DNS requests tell us what the domain name is, and if there are multiple sites on the tower, then they tell us the one that they belong to. This is the standard Windows operation. And when other software are also installed, like Flash Player, whatever, that loves to look for access points, it will start to synchronize with ntp.ubuntu.com, for instance, to do so. Have you read about this vulnerability that American iPhones provided by a specific provider so it can be used to use the internet. A couple of people knows this for free. So American researchers have found out that, I don't want to mention the provider, the ISP, but on that ISP's network, these fake headers allow the hacker to make the network believe that we are on the network, we are part of the network, and authorized to serve. What other data are? Okay, so these are the data that the client broadcasts, and the client connects to a network because it would like to do some traffic in addition to updating. So practically we can do a man-in-the-middle attack. We are the access point, we are the default gateway for the client, and all traffic is routed through us, which allows us a lot of goodies to do. All plaintext client traffic can be replaced, modified, you know. If we look at an active access, SMP relay, who knows the term SMP relay? Okay, not many. SMP relay is an attack where where we utilize a stupidity of the Windows SMB protocol, allowing us, if we can make a Windows-based computer to connect to our SMB server for downloading a picture, for instance, then we can link back with the same challenge that he sent us. So as an end result of the attack, we could even end up being able to execute code, but this needs some luck as well. The client also issues DNS requests. Facebook and similar things are looked for, and the specific IP address that we provided will be used to query. We are the ones they will query in this case. In which case, cross-domain policy is dead, because if I say that it should download XSS a script from XSS whatever, and then the client asks what is the exact email URL, and we tell it our URL address, our fake URL address, which would then allow us to inject things into anything. And the third interesting area is, obviously we are on the same network as the client, and from this point onwards we can do anything, sending exploits, owning the machine. This reminds me of a very cute little film. Okay, you know why I showed it to you. Whatever the client does will harm it. If it tries to browse something, we'll attack it. If it doesn't, we attack it. If he issues a DNS request, he'll get the response we give it. So it's a pretty severe threat.
Now, for this reason, and obviously it was not us, we were not the first ones to realize this and to recognize this. Therefore, some other people looked around. I didn't smell the air, but I'm sure that at least there is at least one DNS exploit which would do another very, very nasty things, in addition to what's written by the entrance that don't link here. Free internet, free public Wi-Fi, HP setup, or any. Any was a network at as an airport. This was my favorite. It wasn't easy to find it, because there were like 15 access points sending the same. Now, this type of attack, if there's a malicious attack, then obviously it is worth finding a place where there is high traffic, a lot of laptops, and then people are quite often waiting, you know. They just look at what sort of networks there are. So networks, airports, plaza, shopping malls, cafes. These would be typical places to use these exploits. Now, there are a lot of tools that you can use. You can use a lot of things. Karma exploit. Who knows the karma exploit? It's a metasploit. Who knows that? Now, the karma exploit is a metasploit. Metasploit, do you know what a metasploit is? Yeah, okay. That's an addendum to the metasploit. Actually, it shoots up this access point, and when the network is being set, then it launches the DNS server, and launches a lot of fake POP3 server, IMAP, FTP, and so forth. and the Metasploit, the protocol is implemented properly as long as the client, actually the customer tells the password. So when we connect these together, and if someone wants to connect to IMAP, and then also clicks on the certificate button, then he will see an IMAP server before he asks. Because obviously, when you ask for your mail, then you don't find your mail, but your password has been stolen. The same is true. Web traffic can be done very well. Beef, does it ring a bell? Beef. This is a tool that injects a JavaScript into any page. So between the client and between the server, like there's an access point, the default gateway, and then all the HTML pages, into all of the pages it would put a JavaScript, a small JavaScript, which JavaScript would force the browser to to connect to a malicious server like our server, and then we can steal anything. We can steal the clipboard and quite a lot of things. I think you should look into it, because a lot of nasty things are available or can be done with it. SMB shares here. Now with SMB sharing, if the client connects to that, and we as a server have a pre-hard-coded challenge, then the based on the client's response, we can just reverse engineer the password. This is like 40 gigs, and this challenge can be used then to obtain the user password by injecting a link to the page showing at a certain showing a certain picture. Now, since we were testing the tool, there were two very nice stories happening. One was that I traveled a lot those days, and at one of the airports I was playing with this tool. It was very difficult to put it together in the beginning, and then I boarded the plane, we took off, and I said, there's no one, because no one wants to connect to me. Anyway, this is going to work then. And we are flying in the air, like, 12, 13,000 meters. And then I said, Airbus Internal Control System Wi-Fi. This is what I named my network. And I'm sure no one would try to connect. There's nothing here. If it works, then it works. And it started to work. And then like 10, 15 seconds, someone came. And what do you think the first page was he wanted to open in the browser? We are flying 12 kilometers high, and then Airbus internal Wi-Fi network. This is what the chap, the bloke, logged onto. Youporn.com. This is what he wanted to connect to. And then I was again testing the tool somewhere, when the SMP challenge thing, what you can use to reverse engineer the password. So when the user is browsing, then the HTML page, you have a one times one picture. Look at this JPEG. This was actually this, and if there is no domain, there is no Windows domain connected, then tries an authentication. If it doesn't work, then there is a window saying, "Hi, friend, here's your password." Now, if someone is really taken by that, then that's really silly. It's really stupid. But that stupid bloke came, and then the chap connected, and there were like 150 logins in like 50, in a short while, and then on the internet I found which word list he was trying. So he tried to hack my malicious access point. And then the second part of the story. How much time do I have? Okay, so while I was telling this to you, this was the theoretical background, and the company where I'm working, we had a work, and our job was to carry out this attack. Actually, the customer said we can do anything. He just said we should obtain certain information. We could use social engineering. We could go there. So a lot of things we could do. And the idea was, this was a 802.1x authentication. And I was in the group, which group said that we should do this attack against one of the employees because they have beautiful networks and probably they use the beautiful computers, laptops at home as well. So this seems to be a good target. Social engineering part, this is something I will talk about later. We anyway found out that we would do this attack, and this is how we would get this certificate. And what were the problems we were faced with? This Tom and Jerry thing works very well in a lab.
Megcsinálja, lefordítja, megpatcheli az eszközöket, elindítja a kis scriptjét, működik, örül, tényleg ott van a háló.
You put it together, start it with the script and everything, the network is there, and if the Windows client is asking for some network, then the network will lie that that this is the network, so it works properly. But it's one thing that you do it in a lab, and another thing if you can do it in the field with a specific client, with a specific environment. Now, this is something I haven't read too much about, because most of the presentations are over after the previous slide, saying that yes, this is an attack, you can do it. But if we really want to do it, then there are quite a lot of minds. Who are the ones who read Wi-Fi security book? Articles, anything about Wi-Fi security? Good. Now, who's the one who read the part about the antenna? Because normally this is chapter 1 after the preface. 2, 3, good. Okay, everyone just skips this part, although this is very important. Because when there is such a specific work, what matters is what sort of antenna you use. This small black antenna, this is what normally comes with the tools, with the devices. And the characteristics of this small antenna does not make it possible to direct it. So this is getting weaker and weaker with the distance. And with some other antennae, like the Yagi and some of them put here, the characteristics are absolutely different. And we should start playing around with them, because quite often the problem is, when we want to hack such an access point, or we want to pretend that we were an access point, we are not being heard by the target. So if the client doesn't hear us because our beacons are too weak, then they is not going to connect to us. And then the other thing is that when you use this in the field, then obviously you run it from your battery. And then in order to save the battery, then obviously your transmit power is going to be reduced. by the system. Now, next one, what sort of environment should we start doing this? I did this on Heathrow, a screenshot. What a Windows client sees, what is in the air. This is like 50 some access points, 3 to 4 different networks. I don't know who the free Wi-Fi was, it wasn't me. So what comes from that is that so many access points, these are all physical devices, and it's quite a lot of noise, okay, from our perspective, because we, as small laptop users, cannot compete with the transmit power of the big devices. Therefore, this is one of the shortfalls. So if you try it this way, then it is like as if you're at an Iron Maiden concert and you want to listen to music over your phone. And obviously, this would still result in the fact that our client is not going to hear us and see us, and therefore not going to connect. Therefore, let me show you a video after this slide. This was the part when there is quite a lot of access points around. And also, if there are a lot of too many clients on the other side, that's not good again. Because the clients, as I said, they're all transmitting. They're all actually are shouting after their own known Wi-Fi networks. And if we try to answer all of those calls, then our device is not going to be able to transmit so many beacons. That would be enough to pretend that you were all of those access points. Let me show you a video. This again is an own video. A lot of the Wi-Fi client concentration here was quite big. Okay, this is real time. What you can see the time, but this is real time. You can see that so many access points. You cannot pretend that you were all of those access points with your card alone. So the other thing is that when we do this specifically, we don't want to pretend that we are so many access points, because we want one MAC address, what the access points want to see, and this is what we want to do. And therefore, we have to take very good care about that. I talked about this tool, this device that we made. Let me show a couple of videos about it. Now it's launched. I don't know to what extent you can see it. You can see those letters, but nothing. You cannot really read it, what's written there. Anyway, just believe me, this is it. So what's happening, and there's nothing homemade here, home developed here. Everything is just internet downloaded, like the Karma exploit I was talking about. Then here's the Metasploit, which is running here. You won't be able to read it, so therefore you must believe me. We use the SSL trip, which is Merlin Spike's creature, and from the HTTPS connection, it always kicks back the client to an HTTP connection. So what it does, if you're on HTTPS, it will guide you back to HTTP. And then obviously the browser is not going to cry for the authentication or the certificate, because there's no certificate in the first place. So, as I said, when there's an XP client connecting, what happens? This is when this is a virtual machine which has a physical net card. The network card will be visible quite soon. Again, this is something you cannot read from the back, but as soon as you find the network controller, then it starts shouting for the networks that it knows, and we are going to give him the network he wants to get. I mean the one he knows. Okay, this is the Wi-Fi card, you can see, and the GU V01, this is the Wi-Fi he's looking for, and he has already connected to us without us doing anything. I stop it. I don't know to what extent you can see, but the DNS requests show that he's living in dummy domain. He does a lot of other things as well, but as soon as it's here, they start to transfer through our network, so generate traffic through our network. And the other thing which can be very funny is when you launch this device, then there are quite a lot of smartphones which say, oh, there's Wi-Fi here, and immediately they just connect to it. And it is really, it hurts you, it is so bad. So if you do not switch on the MAC filter, then an abundance of iPhones and Blackberries just want to connect you. And then this is a noise for us when we're testing, so we don't want that. And therefore, the solution is you should attack in an isolated environment. That is an ideal world where there is only us, where we only us and the prey, and only us as an attacker too. And we should also apply client filtering. To go back to work, we have to know what the MAC address of the prey is, because without that you won't be able to filter, to single out him from anyone else concerning the requests. And then, and this is nothing, this is all nothing so far, because the client has joined our network in quote unquote, because this is a difficult issue what to do, because probably we have only we can only do it once, and then if we screw it, then the client is going to realize that this is not a good thing. So probably we won't have another chance at going at it. So now we also need our client, you know, to connect to us, and then the client does nothing. He just connected to our network and does nothing. Like, let's say, just starts typing in a report. This is very frustrating. That you have it, is already in your trap, but is not having any activity that you can drill into. So, and then you're sitting there and waiting the chap to do something, and he's doing nothing. He's just sitting, hanging on your network. And then you say, okay, let's attack. Let's turn the whole thing around, and let's let it be ourselves who attack. What sort of exploits should we use then? The problem is that you query the vulnerabilities. You have a number of vulnerabilities, and then obviously you want to have a stable exploit, because you don't want to crush the computer of the prey, or you don't want to freeze the computer of the prey, because then again you can do anything, because you don't have another shot at it. Or you do all of them. I mean, send all of those exploits. Now this device does this because it has everything on stock, and then whenever the client starts to do something, then he will attack with the right tool. We use the MS0867 to attack the client. This, in case of success, would give you the local system rights, system admin rights, no, system rights. And this is what we did, and it was successful. And this gave us two conclusions. That is that the patching is not, the last patching was not really strict, because that was. This was a 2 years old exploit, and it wasn't patched out yet. And then from that point on, that we have an access to the client from the registry, we could take away the certificate that it takes to join, to connect to the enterprise network, the corporate network. So then we attack the client, because the client the client's defense was obviously much less effective than that of the corporate or the enterprise network. And this is what I wrote here. Social engineering guys also managed to get into the server room, and then they entered the server room with a pen. They just put a pen there. Anyone who opened the door, the pen just fell in and didn't let the door close back again, and they were able to go in. That's what they did. And then the guys, they also submitted the pen with the report saying that this is the pen we used to get into the server room. Now, what are the lessons learned? First of all, as I said, this approach is bearing its fruits. So don't attack the part of the network that is strongly protected, attack the weakly protected parts. And the weakly protected part of the network is obviously with the guys who have access to it and have their own devices. So it is very important that these guys should be trained. They should not leave their Wi-Fi on, and they should not automatically connect to networks because what I said immediately, the client also has the opportunity to make sure whether that's the person is looking for and not a malicious access point. Now, the third thing, the SMB and all the things I told you in the very beginning, what you can do with the client if it's connected to a network, that takes no joker access point to be turned in. So if you just launch a free internet Wi-Fi, because there are a lot of free Wi-Fis, and then when anyone connects, you must consider that this is a very unreliable environment. So whenever I go to a hotspot, I have the SSA fingerprint so that it cannot be faked or falsified. Now, that's activated. That's actually the thing I wanted to tell you. I have like 10 minutes to go. No. Okay. So this is time for questions. The floor is open for questions. Social engineering with the pen. Well, the task here, there was a B team, and what were the things that you have to do? And I think it had to be documented, photo documented that they were in the server room, and there was a very nice try that they also managed to hook up on the internal surveillance camera system, and it was also a target, an objective there, that the shots of the internal security cameras had to have there. So they have a screenshot with like the 5 pictures of the 5 security cameras, and then there were 5 guys holding a paper in their hand saying "out." So the question was how did the social engineering part end? Well, it was a success. Good. I don't see anything of you. This is about the antenna, the aerials, okay? So Yagi antenna, if you use that, that's a quite good directional antenna, so you can shoot your beam to the infinity. And if we just, target the client, he's going to hear us, but how are we going to hear the client? So yes, it's absolutely correct, the question, because it is it's a two-sided coin, and you just have one side. So you have to either go closer to your prey, or you have to select the location of your attack in such a way that you hear the reverse traffic as well. And the same thing is that if we try to if we try to audit a very remote access point, and the access point has a very strong a very strong transmission, so we can hear it, but that is not going to hear us because our output transmitted power is not that strong, strong, yes. So you still have... Okay, so the comment here is that the Yagi, you need the Yagi to make you as the strongest network, so that you would be the preferred network, and not only to reach the client. Yes, the answer is yes. So the objective is not only so that our prey would listen to us, but that it would choose us from among the lot of access points. Obviously, the point of the attack is not that we are much stronger than all of the others, so we are not sort of trying to jam the other access points in order to force the client to choose us at the reassociation. This type of hack also exists, but this is even more difficult. So it is easier if the client voluntarily chooses us, because we are transmitting an SSID which the client very much would like to see and hear, and then he would choose us. Another good question. He said VPA, WPA, or other type of security key. Does it work with that as well? The fact is, yes, it does. Because the logic of the attack is even before the client would start to trigger traffic, initiate traffic. Obviously, it is their own preference, the client's own preference, because in the SSID of the Wi-Fi network and at the handshake, this is again regardless whether there is security or not. And there is a handshake at the beginning, capability handshake, and then the network will tell you what sort of security protocols it does support and what it doesn't, and this is how you can find out to what extent it's secured and not. As an attacker, we always launch an unencrypted access point, because you could shoot any other access points like with WPA or VPA, but then that's a further problem, because then the clients would like to use their own key. There are certain attacks that are using this, and this is like a web cracking, but this is not what we use. We do not. We are not interested in what the network security key is, because this is not our objective. Oh, I don't know if it was understandable or clear. So the question was that if we design the attack in such a way that our network is, our machine is not transmitting into the air, into the free space as an access point, but in such a way that it's already connected to some network, then obviously the client is not connecting to the network, but connecting to us. However, we can channel his traffic to the network we're connected to. And then we're in the middle, and this is how we're doing the... Yes, it is possible. There are such attacks. This is quite similar to what we do, but this starts out from the fact that because of lousiness, certain people leave the Wi-Fi on even if they have the cable plugged in. the network cable, but obviously on my machine you can set the BIOS in such a way that if my machine is if my computer is plugged into a network cable, then the Wi-Fi is off. But if not, that's not the case, it may happen that both do work, so that you're hooked up through the cable, and then still you have the Wi-Fi open, and then you can do the same attack. And this is something that exists, and they really do it. So they go to the you enter the network, the secure network through the client. Okay, thank you very much for your kind attention. My time is up. And should you have any further questions, notes, remarks, you will find me after the presentation. Thank you.